eyes are swollen shut.
Alright, so I hope you guys know that the video that we made last night is posted.
Video!
Look, except I don't know, the camera for some reason did it in 2 parts, so I posted it in 2 parts.
Oh, it's pretty
But
long.
on there. So when you study for the test on Monday, you probably want to look at that again because most of you forgot everything that happened.
No.
Everything that happened? No. What?
Okay, so we were supposed to catch up now, so your catch up, it doesn't matter. You just got to do all of this work by the time the next test comes around, right?
Would you say it's hard work?
No. The hard work was the first chapter.
Cool.
Okay, so today what I'm going to do is I'm going to lecture on both 3.1 and 3.2. What? That's the way it is, man.
Okay. Wait.
Hey, do we
What
have
are we-
basic again tomorrow?
What are we doing tomorrow?
After we discuss the homework that probably you're not going to do, play games or something.
Yeah.
No, listen to synthesizer music.
Yeah, we can do that.
Wait, we should have another
I mean, I don't
story.
care what we do.
We could
It's going to be
do
fun for me. I don't know about you guys.
the band.
Okay, here we go. I didn't tell you the story of my band.
No.
Okay, after this then.
Okay, what?
Okay, 3.1. Now we're going to learn about derivatives. Now, what is this? The limit as h approaches 0 of f of, say, 2 plus h minus f of 2 all over h. So if I compute this difference quotient and take the limit as h approaches 0, what does that compute?
The instantaneous velocity.
The instantaneous rate, or the slope of the tangent line when x is 2, right? Just look at that number there. But that's only at x equal 2. Is there like another way we can find the slope of the tangent line at any value of x, not just a particular value of x?
Go down x.
Yeah, just instead of putting a 2 here, put
X.
x. That's right. Now if we compute that, we call this the derivative of the function, and it's denoted by this, f prime x.
Are we learning the shortcut?
No, you cannot use the shortcut
But it's chapter
until
3.
3.3,
Oh!
which is next week, Tuesday.
That sucks.
So even if you learned the shortcut last year, you can't use it. So I will box this because that's what you're going to use on tonight's homework. Okay? So here, let me give you an example. So suppose you have a function y equal x squared. Compute its derivative. Okay, so you just do this right here. Limit h approaches 0. F of x plus h means you substitute x plus h for x, minus f of x, which is the given function, and divide the entire critter by h. So we should be experts at that already. And then now, if I plug in 0 for h, it comes out 0 over 0, it's indeterminate. In fact, it's always going to be indeterminate. So you're going to have to do something. So what do you think I'm going to do here to compute this limit?
Expand.
Yeah, simplify. So multiply that out. You guys can handle squares, but once I make it cube, all hell breaks loose, eh?
No.
Yes. That's what happened. When x squareds cancel out, like they always do, can I factor out an h on the top and cancel it with the h on the bottom?
You bet your sweet.
You bet your sweet
Bippy.
bippy. It's like, it's
Stop copying
you could
my
have saved problems over and over. The h's cancel out. Now can I plug in 0 for h and get something?
Yeah.
Yeah, what?
2x.
2x. This is the derivative of that function. So if somebody were to ask you, what's the derivative of x squared? You say 2x. Now, what does that mean? The derivative is like a formula that computes the slope of the tangent line. So here, let me show you what's going on. So, here is the graph of y equal x squared. That's the function that we just computed the derivative of. At any point, its derivative or its slope is going to be 2x, 2 times the x coordinate. So here, at this point, let's say this is the point 1 comma 1. Okay? Draw in what you think is the tangent line right there. What's the slope?
2.
It's 2 times the x value. So since the x value is 1, 2 times 1 is 2. That's the slope of the tangent line. You can compute the slope at any value of x. Okay, here's another point. Let's say this is the point negative 2 comma 4. Draw in the tangent line. What's the slope? Look, 2 times the x value. What's the x coordinate? Multiply it by 2, -4. That's the slope of the tangent line. So the derivative is a formula for the slope of the tangent line at any value of x. Okay, let's do another one. Way up here somewhere. How about like 3, 9? Now it's getting steeper, yeah? Like that. What's the slope of the tangent line right there? Well, just look at the x value and multiply it by 2. It rhymes with Hicks. 6! And then what about here at the vertex? Here's the vertex, 0, 0. Well, what is 2 times 0? So does it make sense that at the vertex, the slope of the tangent line would be 0? Yeah, it makes perfect sense. So the derivative is a formula that tells you the slope of the tangent line. So tonight's homework, they're gonna give you like, I don't know, like 1 over x, radical x. You have to compute the derivative, and then we're gonna do the same thing as we did in the last chapter. Write the equation of the tangent line, and then write the equation of the normal line. So like right at this point, we just figured out the slope is -4, correct? Can you write the equation of this line? If you have a point and a slope?
Yeah.
Yeah, just do point slope form. Y minus 4 equal -4x plus 2. So that's the tangent line. What about the normal line that's perpendicular to that? What's the equation of that? Same thing, except
Reciprocal.
the slope is, no, not the reciprocal.
Negative
The
1/4.
negative reciprocal. So instead of -4, it's
1/4.
1/4. That's
Correct.
that's the equation of the normal line. So it's pretty easy, right? But see, the derivative is more convenient because we can compute the slope at any value of x rather than just at a particular value of x. Well, it's more useful. Now, 2 other things you're gonna have to know for tonight's homework. Even though we're covering 2 sections, the lecture is quite short. Here. If I give you a sketch of a function, you have to be able to sketch its derivative, okay? So, let's start off with an easy one. In fact, I think this is the same one I gave on last year's quiz. In fact, I probably put the same thing on the next quiz, and some of you probably forget anyway. Okay, so sketch the derivative of this function. See, it's just like here. You had y equal x squared. What did the derivative come out to?
2x.
2x. So it looks something like this, huh? That's what the derivative looks like. Okay? But you have to sketch it, and how do you do it? Well, you have to understand that the derivative tells you the slope. So the first thing you should do is find where on this graph is the slope 0. Like, where is the slope 0?
Boom.
There
Boom.
and there, correct?
Correct.
So right at this point, you plot 0.
Huh?
Because the slope is 0. The derivative is the slope. What about there? Go down there, you plot the 0, because the slope is 0. You're just
Yeah.
plotting what the slope is, that's all it is.
Yeah.
Okay, now, you got these 2 zeros here now. What you do is you just look to the left of it. Now, to the left of this point, what can you say about the slopes?
They increase.
Look at the slopes. Just tell me, are they positive or negative?
Negative.
Yeah, if it's coming downhill, it's negative. So what you do, so you know the graph is going to be below the x-axis. It's going to be something like that. It's negative, right? Now what about in between here? What can you say about the slopes between these 2 points? Look, they're positive, so now it's going to go above. And then look, see? And then look, now it's starting to flatten out, get closer to 0, so it goes like that. And then what about on this side? What can you say about the slopes?
Negative.
They're negative, right? And they're getting steeper, right? So that would be a sketch of what the derivative looks like. So the easiest thing to do is find out first where the slopes are 0, and then look at the regions, you know, to the left and the right. It's quite easy. Now you can kind of see why finding the slope of the tangent line is so important, because when you have a function, like say you're in business, here, that's not realistic. Let's say you're in business and you have something like this. This is like quantity versus profit. Now, if you're a business person, okay, I don't like this, maybe something like that. What would you rather have? Would you rather have maximum profit or minimum profit?
Maximum.
Or minimum could be there, yeah. Anyway, so how do you locate these maximum or minimum points? Like if you have a maximum point, what do you think?
0.
Yeah, when the derivative is 0, when the slope is 0. And same thing for minimum. If you want minimums, you just compute where the slope is 0. It's quite easy. So that's why we do it. Okay, and then the other thing you gotta do in tonight's homework is you have to be able to draw the graph of a derivative on your calculator, and then you have to kind of identify what that is. Okay, so hopefully you have your calculator today.
Wait, did we do this in PCH part?
No, I didn't teach you this in PCH. Okay, let's do an easy one. Sine x.
Super foreign.
Okay, let's say you have the graph of sine x. What we're gonna do is we're gonna tell our calculator to graph the derivative of that, and then we're gonna guess what the derivative is just from that. That's what you're gonna have to do in tonight's homework. So let me show you how to do it. Take out your calculator. You guys even have it? Come on. Now, since we're doing trig functions, you want to make sure that you're in radian mode again, because if you're not, you're in trouble. So how do you tell your calculator to graph the derivative of sine x?
There's gotta be a way.
Okay, are you guys ready? So you press options, and then you see calculus right there, the calculus button, that's F2, press F2. And then you see d over dx, that's like a symbol for the derivative. So select d over dx. So you're telling your calculator, graph the derivative of, what do you think I'm gonna put in that first box?
Sine x.
Sine x, so where is sine? Sine x, right arrow, and then what do you think I'm gonna put in the second box? See, so what your calculator does, it computes the derivative of sine x at whatever value of x you tell it to. So like if you put a 2 in there, it computes the slope of the tangent line when x equals 2. But we want our calculator to graph the entire graph, not just when x is 2.
Equals x.
So yes, exactly. So you put x in that second box. That's not even funny. Okay, and since we're graphing a trig function, you might want to go into the trig, V window trig. So go to V window, and let's select trig, because it's a trig function, right?
Cool.
Exit, draw.
Whoa!
So what it does, what your calculator is doing, it's computing the slope of the sine graph, and it's just plotting that point every time. And it puts all the points together and go, hey, you somebody, huh? Doesn't that look like a graph that we're supposed to know?
Sure.
What is it?
Cosine.
Exactly. Okay, so I gave you an easy one to start with.
Thanks.
Okay, so let's try another one. What if the function is cosine x? Graph the derivative on your calculator and then guess what the derivative is. Try it. I'll race you. Hey, you better bring your calculator.
I know.
Negative sine x.
Wait, I'm not even there yet.
Yeah, you said you'd raise,
So-
and you got beat.
Hey, see what you made me do? So you can just go to the thing, delete the sine, and replace it with a cosine. Woo!
I started when I asked.
Okay, draw.
Ah! I'm just for like 2.
Then you look at that thing and you go, hey,
Like a 3-hour nap.
you somebody.
This is what my thing looks like.
Are you in radian mode?
Yes, I just changed it back.
Are you in V
I see.
window trig?
Yes.
No.
Oh no.
No further questions, Your Honor.
I can press enter.
No.
Okay.
So strange.
So you're looking at the graph.
Exit.
So what was your guess? What's it
Your
called?
money.
Negative cosine.
No, negative sine.
You literally said negative
And that's,
sign.
these are actually correct, okay, but they don't come out nice like this all the time. Okay, we're gonna do another one.
Oh, did I get like a power series?
Okay,
Is that
let's
part of
do,
this?
no, we're not, AB, in AB, we don't do power series. That's a BC.
Dude, power series
Sit
is so
down.
hard.
Sit down.
It's the worst.
Thank the Lord.
Well, if you go to college and take second semester calculus, then you're gonna know it.
I never got
It's a good
that.
thing I'm.
Okay, graph the derivative of tan x on your calculator
I don't
now.
want to memorize it.
Come on, come on.
Alright, what do you want me to do?
Oh, God.
Calculate.
That's just gonna be a really messed up graph.
How's it gonna be cotangent?
So change the cosine to a tangent now.
It's gonna be like a bunch of lines.
Doop, doop. So it's a hump up, hump up, hump up, hump up, hump up. Now, if it were a hump up, hump down, hump up, hump down, that might be recognizable. But we have a hump up, hump up, hump up, hump up, hump up.
No.
So what would your guess be?
Absolute value is secant.
Okay, that's a good guess. Absolute value of secant x, because everything below would get reflected above, so everything would hump up, right? But that's not quite right.
Ah,
So, is there another thing we could do to make it all the negative values
Square
become
root of
positive?
secant squared x.
That's the same thing as
I
x.
know.
Huh?
But you asked if there's another thing.
How about just secant squared? Because if you square negative numbers, they become positive, right?
Doesn't that change
Anyway,
their values?
if this is your guess, you're correct. But we're going to actually derive it later. You don't have to worry about it.
Wait, doesn't that change their values?
Yeah, so that's why that's not exactly a secant graph. It's secant squared. Okay, let's do one more, and then the next time you're gonna see it on your homework, and then next
Is
week
there-
we'll have a
is
quiz.
there-
You're gonna have to prove to me that you
That
can do it.
Michael B.
How about x natural log x minus x? Graph the derivative of that, and guess what the derivative is. Okay, you know what? I know what the. I don't need to graph this on my calculator. I know how it's gonna come out.
is it E?
No.
It was just
How about try do it on your calculator?
I didn't.
Okay, if you graph the derivative of this on your calculator, you should see something that looks like this.
Yeah.
Right? Everybody got that?
They just
Hey,
show-
you somebody.
uh,
Natural log x.
Oh my goodness.
Come on, that's a base graph, people. Like, okay, I admit, this one is kind of difficult, but all the other ones, those are base graphs. You got. Okay, that was the lecture for 3.1. Pretty easy, huh? It's not that hard. You know, the calculus, like I told you, calculus concepts are not that difficult. You know what's going to be difficult for you guys?
Trig.
Algebra, the pre-calculus stuff. Exactly. And just wait till we get 3.3. You got to simplify all your answers. That's where the craziness is going to
That's
begin.
easy money. 3 points wherever you are.
Okay, 3.2. This word, differentiable. We need to know what this word means, differentiable. Okay? Well, basically, if I say a function is differentiable at a particular point, that means it has a derivative. It has a slope. That's what differentiable means. Now, what does that mean in terms? Well, basically, in layman's term, differentiable means smooth and continuous. That's what it means. So, like when you have a polynomial function, polynomial functions are always smooth and continuous. There are no sharp points. There are no breaks in it. So, polynomial functions are always differentiable. But sometimes we have functions that look like this. I'm going to try to get everything in because I see a lot of you didn't bring your books today. So,
Okay.
okay, I'm trying to draw it. So silence. Wow. That's not good enough. Wow. Okay, I like that better. Okay, so they're going to give you a graph on tonight's homework and they're going to ask you, where is the graph not differentiable? Where does it not have a derivative?
Boom, boom, boom.
Okay, so right here.
Ah, yeah, that's one of them.
It doesn't have a derivative there because that's a sharp point. We talked about that already, right? But your book calls this a corner.
Really?
Yeah,
I call
it a sharp point.
Oh.
And the reason why it's not differentiable there is because the left-hand slope is not the same as the right-hand slope. Right?
At that point.
At that point, exactly. Okay? So here, why don't we call this A? So when x is A, the function is not differentiable there because you have a corner, a sharp point. Okay, what about at B? Is this function differentiable at B? Does it have a derivative at B? And the answer is no, because it's not continuous. If it's not continuous, you can't have a slope there. Okay? Anyway, if you look at your book, it has all of these cases in it. But again. Okay, what about right here at C? Is the function differentiable at C? No, because again, it's not continuous. If it's not continuous, then it doesn't have a derivative. What about right here at D? Is the function differentiable at D? No, but we can call that a sharp point if you want. But you know what your book calls this? Anybody? Anybody read the book? No, it's called a cusp.
Cusp.
It's called a cusp.
Ah, the cusp.
And then finally, what about here at E? Is the function differentiable at E? No, because look, if you were to draw in the tangent line right there, it would be kind of like that, it would be vertical.
Oh.
And what's the slope of a vertical line?
It does not exist.
No, it's undefined, yeah?
What?
So these are all the different ways a function cannot be differentiable, okay? So like tonight's homework, they're gonna ask you, at what values of x is this function not differentiable? Then you would just say at x equal a, b, c, d, and e. Simple as that. Or where is this function differentiable? Then you would say everywhere except at x equal a, b, c, d, and e.
Are we gonna do like probability and stuff?
No, there's no probability in calculus.
That's cool.
Okay, so do we know what the word differentiable means? It means it has a derivative. There is a slope there. Okay, now last example and we're done. Now this problem is always on the AP exam, every single year. Now let's go less than or equal to 1. And then how about 3x minus 2 when x is greater than 1? Okay, let me ask you some questions about this piecewise function here. Is this function, this is good practice for Monday's test by the way, is this function continuous at x equal 1?
Yeah.
Okay, how do you know?
Plug it in.
Because if you plug in 1 here and you plug in 1 there, you get the same number, so they actually meet. And if you want to draw the graph, you can. Okay, so here's 1, a parabola looks like that, right? And then now it's 3x minus 2, you plug in 1 there, you get 1, and it goes up like that. Okay, so it is continuous, and then explain. What's the reason you're going to give on Monday? Why is this function continuous at x equal 1? Because if I plug in 1 here and 1 there, you get the same number? No.
The slopes on both.
I told you guys what to write. It was just the other day. Because the limit of this function as x approaches 1 is equal to
1.
f of 1, and they're both equal to
1.
1. Bam!
Wait, do we have to put f of 1 equals 1 too? Like,
Wait, let me look. Yeah. I told you exactly what to write. I'm trying to train you guys for the AP exam, but you guys are thwarting me.
thwarted it.
Okay, now, you know what's continuous? Is this function differentiable at x equal 1? In other words, right here at this point, is it smooth, nice and smooth, or is there like a sharp point there? Now, sometimes you can't really tell. So what do? How do you tell? Exactly. Zoom in? But no, but you can't use your calculator. And even if you were to zoom in 10 times, sometimes you still can't tell. So what do we need to do? Okay, again, in order for a function to be smooth at a point, the left-hand slope and the right-hand slope have to be the same. Because look, if the left-hand slope and the right-hand slope are different, it makes a sharp point. So they have to be the same in order for the graph to be smooth. So how do I check the left-hand slope and the right-hand slope? What do I have to do? What are we learning this chapter? Derivatives! We need to compute derivatives. So what you need to do is you need to compute the derivative of this and the derivative of that. And you cannot use the shortcut that we learned last year if you were in my class.
Why?
So let's do the first one. How do we compute the derivative of x squared? Remember what I showed you at the beginning?
2x.
How do you compute the derivative? Limit h approaches 0, f of x plus h minus f of x all over h. You have to compute the difference quotient. In fact, we already did it, right? We did this 10 minutes ago. Does anybody remember the answer?
2x.
Okay, some of you remember the answer. Okay, so here, do the work and you come out with 2x. So the derivative of this is 2x. I'll just write it like that.
It's not this short.
Well, how do I compute the derivative of this? Now, if you're smart,
It's 3.
Shortcut.
okay, very good, it's 3. Why? Why is it 3?
It's a shortcut.
Okay, limit, no, then we gotta do it then, since we don't know. Limit
No.
as h approaches 0, f of x plus h, that means substitute x plus h in, minus f of x, all over h. Okay, now does this simplify because it's 0 over 0? Yes, it always simplifies. 3x plus 3h minus 2 minus 3x plus 2 all over h. I bet a lot of things cancel out. Baguga, 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 baguga. But h cancels into h, so what's the only thing left?
H!
No, 3! 3.
said that.
So the derivative is 3, but doesn't that make sense? If you have a line, think about it. If you have a graph of a line,
Oh yeah.
isn't the
The
derivative
slope is
simply
always
the
gonna be
slope?
3.
Because that's what the derivative is, it's the slope.
It's just a line that's
So when you have a line, the derivative is simply the slope of the line, so, but nobody made the connection till now.
Well,
So, how do you tell if this function is differentiable at x equal 1? Well, to find the left-hand slope, you would plug 1 into here. To find the right-hand slope, you would plug 1 into here. So if I plug in 1 into here, what do you get? If I plug in 1, well, there's no x there, it's 3. Well, is 2 equal to 3? No. So this function is not differentiable at x equal 1 because the left-hand slope and the right-hand slope are different. See, and if you were to just draw the graph, I erased it, you can't tell, so you have to compute
wait,
derivatives.
so
Yes.
you have to do, that's exhausting.
Yeah, wait, you have to do both of that? Like,
Wait, let me look, yeah.
Oh my goodness. Sorry.
Wait, how is it?
But starting on 3.3 next week,
Shortcut!
we're gonna have shortcuts to compute these
Wait, how is
derivatives.
it continuous but also not,
See how
not
it's x squared?
differentiable?
Because the graph comes to a sharp point, look,
And
here,
then
right
minus
here.
1 from the
In
power.
fact, this is a problem on
That's
your
why
next
now-
quiz.
Yeah.
Let's see what we can do.
Right here, let's say that's 2.
Shortcut!
When x is 2, look, the function is continuous, there's no break in it, but it's not differentiable.
Ah.
Ah,
It's continuous,
okay.
but it doesn't have a slope because the left-hand slope and the right-hand slope are different. Okay, we are done.
So,
Story
Wait,
time.
we're not done.
the derivative has to be the same.
Yeah, the slope's gotta be the same. The left-hand slope and the right-hand slope gotta be the same number. But
Yeah!
they're not, right? Because
We normally collect
if you
contact.
plug in 1 here, you get 2. If you plug in 1 there, you get 3. Is 2 equal to 3?
Yeah!
No, so it's not differentiable.
With imaginary numbers, it could be.
Oh, so you can have a different derivative, but if you plug in the number.
Yeah, when you plug in the number. Because you only get the slope when you plug in the number, that's right.
Okay.
Yeah.
Actually, I don't think you can see. Look at that. Are you gonna tell the story?
Yeah,
But
can
she's
I
like-
turn off the camera first?
No!
Why don't you want to turn off the camera?
It's like the Bible book.
Because we're not having that story on the camera.